Okay, hi, I'm Hannah Irish. I'm going to be doing number 19. Okay, so number 19 says a playground is on a flat roof of a city school 6 meters above the street below. The vertical wall of the building is 7 meters high, forming a 1 meter high railing around the playground. A ball has fallen to the street below, and a passerby returns it by launching it at an angle of 53 degrees above the horizontal at a point 24 meters from the base of the building. The ball takes 2.2 seconds to reach a point vertically above the wall. So part A wants us to find the speed at which the ball was launched. So that's not an X or Y component. It wants us to find the actual speed. Okay, so first we're going to fill in what we already know in this helpful t-chart. Oh, by the way, I defined up and right as positive X and Y. Okay, so we know that the speed for the X direction is going to be V, which we need to find cosine of 53 degrees because that's the angle that we have above the horizontal. And the final and the initial are the same because it does not have acceleration, 0. We know the time is 2.2 seconds, and we know that the displacement is 24 meters because it tells us so. Okay, so this means that we know that the initial velocity of y is also v sine of 53 degrees. We don't know vf, but we know time is also 2.2 seconds, and a is negative 9.8 meters per second squared because we defined up as positive. Okay, so what we need to do now is we need to find v. So I'm going to use the x direction, and I'm going to use the kinematic delta x equals VOT plus half AT squared, and we know acceleration is 0, so that cancels out. So we have 24 meters equals V cosine of 53 degrees times 2.2 seconds. And then we just do some algebra. And V equals 18.1 meters per second. So that's part A. Okay, so part B asks us to find the vertical distance by which the ball clears the wall. So it's going to be over the wall, okay? So what we want to do is, now that we have V, we can use that for our initial velocity of y. So we're going to do the same kinematic, but this is in the y direction. So delta x equals VOT plus half AT squared. So delta x equals 18.1 meters per second times 2.2 seconds plus half times negative 9.8 meters per second squared times t squared, so 2.2 seconds squared. And that is going to give us 8.09 meters. Okay, but it didn't really ask how high the ball goes. It asked how high does it clear, by how much does it clear the wall. So we know the wall is 7 meters, including the playground fence and the building. So we get 1.09 meters is our answer for part B. And the reason we use 2.2 seconds as time is we're not trying to find the max y. That's really important to know. We're trying to find when it's here, and at here the problem told us it's 2.2 seconds. So it's not the maximum y displacement. Okay, so part C, don't know where I am. Okay, find the distance from the wall, so from the wall to the point where it lands on the roof. Okay, so there's something that we need to know when it says that. So first of all, we're going to be finding an x displacement, and we're going to need to subtract out 24 meters because it's not asking from the starting point, it's asking from the wall to where it lands. Another thing that we need to know is that when it's landing, the y displacement is going to be 6 meters because it's landing on the roof. That's really important. We need to use that. Okay, so we're doing y direction here. My pen just broke. And we're going to use delta x equals VOT plus half AT squared, and we need to solve for time. So what we're going to do is we have 6 meters. We know, again, initial velocity is 18.1 meters per second times sine of 53 degrees t plus half times negative 9.8 meters per second squared times t squared. Okay. So now we're going to need to use quadratic formula, so I will rearrange it in a way that looks nicest to us. So negative 4.9 meters per second squared t squared plus 18.1 meters per second times sine of 53 degrees. If you want to enter it into your calculator worked out, do that as well. Minus 6 meters. So then we're going to use the quadratic formula, which I'm sure you all know, and we're going to get two answers for t. one is going to be 0.5 seconds and one is going to be 2.45 seconds. Okay, so there's two. So we might think, okay, which one do we use? But we have to think about it logically. So we're launching the ball here. It's going up and it's landing on the roof. So that means it's going to pass 6 on the way up and it's going to hit 6 on the way down. That's why we have 2 times. So what we need to use is the later one because it's landing. It's on the second half of its trajectory. So our time is 2.45 seconds. And now we can use it in the x direction. So again, delta x equals VOT plus half AT squared. A is 0. We get 18.1 meters per second. Cosine of 53 degrees because we're in the x direction. And time is 2.45 seconds. And that is going to yield 26.69 meters. And final answer, right? Wrong. Okay, so it didn't ask starting from here. Like I said earlier, it asked from the wall. So we need to subtract that 24 meters from what we got. So 26 meters, or 26.69 minus 24 meters gets us 2.69 meters. And if that's like approximately the answer, if you got anything different, it's because of where you rounded or where you didn't round, but this is the right answer. So 2.6 meters away from the fence. All right, thanks for listening.